Alrighty, so this is going to be part 2 of question number 3 on page number 4 of exam number 3 in relation to the to graphing first and second derivatives and graphing their concavity, slope, and having all their minimums, inflection points, saddles, all that good stuff for this kind of problem. So what I did here, I transcribed some information that we had from last time. So we had the minimum of -2, -27. We had the saddle at 1, 0, and we had inflection points at 0, -1, and 1, or -1, -16 in this case. And then I also transcribed the f of x, f prime of x, and f double prime of x. So what we're asked to do here for E, we're asked to find the intervals in which the graph is concave up or concave down. So as I mentioned before, the first prime f of x refers to the slope of the graph of f of x, and then f double prime of x refers to the concavity of the acceleration, or the concavity of the graph itself. So in this case, you're supposed to set the f double prime of x equal to 0. But then since we already solved that last time, we had that x equal to -1 and 1. So in this case, what we're going to do, as we did last time with f prime of x, is we're going to write a sign chart, and we're going to have -1 and 1 as well too. So now we're going to test a couple points within these intervals in order to see if the concavity is positive or negative. So in this case, we can use f double prime of -2 in this case, which in this case would just be, so -2 to the power of 2 is just 2, or it's just 4, sorry, and then 4 times 12 is just positive, and then -12, that would be a positive in this case. And then from -1 to 1, we can try out f of 0 in this case. So if we plug in 0 into this would just be a negative, and then beyond 1, so we can try f double prime of 2 in this case. So 12 times 4, that would just be 48, minus 12, it would be positive, so that would be positive 36 in this case. So you can see that the positive means that the concavity is going to be up in this interval, and then from interval -1 to 1, it would be negative, so it would be concave down. And then from 1 to positive infinity, it would be concave up again. So before we graph the points that we have, we also want to make sure that we find the x and y intercepts. So to find the x and y intercepts, we would just have to take the f of x and just plug the 0 accordingly. So for the xint, we would have to set this equation equal to 0. So in this case, it will be 3 plus x times x minus 1 cubed equals to 0. So in this case, x would just be -3, and then x will be 1. So these would be the x-intercepts. So we'd have an x-intercept at -3, 0, and at 1, 0 in this case. And to find the y-int, we just substitute x for 0 in the f of x. So y-int, that would just be 3 plus 0 and then 0 minus 1 to the power of 3, which in this case will just be 3 times -1, which is just -3 in this case. So the y-int would be 0, -3 in this case. So now that we have all the information, we have all the x-ints, x and y intercepts, and when we have the minimum, saddle, and inflection points, we can now go ahead and graph this accordingly. So let's start off with the x-intercept. So we have x-intercept at -3, 0, so which will be around here. And we have an x-int at 1, 0, which will be around here. And then we have the y-int, which will be at 0, -3, so which will be give or take around here. So this will be the y point. And then the minimum be at -2, 27, so it'll just be like around here-ish. This will be the absolute min, and the saddle will be at here at 1, 0, and then we have an inflection point at 0, -1 in this case. So let me just rewrite that real quick. So -3 would be right here, and +1 would be right over here in this case. So now if we are to draw it all out, we should get something like this for the graph. So as you can see, from -1 to -1 to 1, it's concave down in this case, and then from positive -infinity to 1 is just positive, is just concave up, and then from 1 beyond it's going to be concave up again. So we can see that the concavity here applies accordingly. And then also at the same time we have all the points given here, so we can just like label them. So we can have min here, or we can have the here or the absolute min, because there's only one min. So there's two types of mins. There's a local min and there's a absolute min. So absolute min is like the lowest min you can have in case you have another min, which would be in that case be known as a local min, which will be higher than the absolute min. And then right over here we have the x-intercepts. So x-int, x-int. And then also here you have the saddle as well too. And a point of inflection, I'm pretty sure, as well too. And then inflection is also going to be right over here as well. It's going to be an inflection as well, just like that. And there's going to be another inflection point right over here. I forgot about the -116 as well. So we're going to have inflection points right here, right here, right here. And then we're going to have a saddle right here because we have increasing slopes twice in a row when it comes to like the intervals. So we have positive and positive with two intervals in a row in terms of slope, and then the y-int is going to be around the inflection point is going to be actually upper here, and then the y-int is going to be right over here. So yeah, the graph should look something like this. So using all the information that we found previously in terms of concavity, in terms of slope, in terms of the intervals, in terms of x-intercepts, in terms of saddles and inflection points and minimums, this is what we have. So this is what it all brings together in terms of the first prime and the second prime of f of x. So yeah, thank you for watching.